You might think baby carrots are simply young carrots, but in reality, in the United States, nearly 70% of fresh carrots are consumed in this form, most of them originating from carrots that were rejected due to not meeting visual standards. So what transformed these small baby carrots into a billion-dollar vegetable snack industry each year? The journey begins in vast carrot fields where they are grown under optimal conditions, then quickly harvested and transported to processing facilities. There, rough, misshapen carrots are cut, polished, and reshaped into uniform, perfectly smooth baby carrots within just a few hours. Today, we're going to explore that journey and uncover what really happens behind the scenes to turn ordinary carrots into the crisp, perfectly crafted baby carrots we see everywhere. In the early 1980s, when a large portion of carrots were discarded simply for not meeting visual standards, the U.S. carrot industry faced growing pressure from waste and declining commercial value. Then a turning point emerged. Instead of being thrown away, misshapen carrots were cut, peeled, and polished into baby carrots, a simple idea that ultimately reshaped the entire market. And whether they are true young carrots or cut from mature ones, their nutritional value remains largely comparable. Few people realize that carrots were not originally orange. In the past, they were commonly found in purple, yellow, and even white varieties, before orange carrots were selectively bred and gradually became the global standard. Beyond their historical significance, carrots are rich in beta-carotene, a precursor to vitamin A, essential for vision and immune function. However, the belief that carrots improve night vision actually originated from a World War II propaganda campaign designed to conceal radar technology. Beyond being a nutritional staple, carrots have also become one of the most heavily mechanized crops in modern agriculture. In the past, harvesting carrots was a labor-intensive task, requiring workers to bend close to the ground and pull each root out of wet soil for hours at a time. But today, in large-scale farming regions across the United States and Canada, specialized machines have completely transformed how carrots are brought out of the ground. Few people realize that harvesting carrots is not actually done by digging them up, but begins with a highly precise pulling motion. As the harvester moves through the field, parallel rubber belts grip the green tops and pull the entire root out of the soil in one continuous movement. Beneath the surface, vibrating blades loosen the soil to a depth of about 20 to 30 centimeters, reducing root resistance and minimizing breakage or surface damage. This leaf-pulling harvesting mechanism is also why the industry can hardly harvest true baby carrots at scale. When the plants are still young, the tops are not strong enough to withstand the machine's pulling force, while the roots are short and fragile, making them prone to breaking or being lost in the field. As a result, instead of harvesting early to create true baby carrots, farmers typically allow carrots to reach standard size before sending them into shaping and processing lines. From the moment they leave the ground, carrots are no longer simply a product of the field. They become part of a mobile processing system right on the farm. Conveyor systems at the rear transport the roots into storage bins while shaking off most of the soil, yet still leaving a thin layer to help reduce moisture loss during the early post-harvest stage. As multiple harvesting units operate in parallel across the same field, a continuous stream of carrots is transferred to accompanying transport vehicles with almost no interruption, allowing productivity to exceed 1 hectare per hour under ideal soil conditions, effectively turning the entire field into a large-scale mobile production line, where the industrial journey of each carrot truly begins. Leaving the field, tractor trailers loaded with carrots move almost without stopping, heading straight to the plant's receiving area, where tens of tons are dumped onto conveyor belts and continuously transferred into temporary storage before entering the fast-paced, water-intensive industrial processing line. As soon as they leave the receiving area, carrots from storage are discharged directly into a deep feed hopper. Here, a cyclone-like water flow causes heavier materials such as compacted soil and stones to sink to the bottom, while the lighter carrots remain suspended and move on into the main rotating wash drum. Inside the several-meter-long drum, hundreds of high-pressure water jets spray continuously from multiple directions as the drum slowly rotates, causing the carrots to roll and gently rub against each other, removing adhering soil without damaging the skin. Unlike potatoes, which often require more aggressive scrubbing, carrots are cleaned using a flow-based washing principle to preserve the thin outer layer that determines their crispness during storage. They then pass through 2 to 3 successive water zones: a primary wash tank, a finer wash with ozone or aeration to reduce surface microbial load, and finally, a high-pressure clean water rinse before moving on to sorting. The entire process takes only a few minutes, yet it is enough to transform freshly harvested mud-covered roots into a clean, uniform raw material, ready to enter the most precise stages of the processing line that follow. Immediately after washing, the carrots pass over an inspection table, where workers quickly remove any roots that are cracked, overly misshapen, or still have remnants of tops attached. Following this step, the carrots are sent through a multi-lane sizing system, where each one automatically slides into its designated commercial-grade category, determining whether it will be packaged whole or sent for further processing. In many modern facilities across the United States and Europe, manual inspection has been replaced by optical sorting systems using high-speed cameras and multispectral sensors. Each carrot is scanned in just milliseconds to measure length, curvature, color, and even detect tiny surface cracks that are difficult to see with the naked eye. Notably, some systems also use near-infrared light to identify internal damage or pest-affected tissue beneath the skin, defects that are nearly invisible from the outside. With the ability to process tens of thousands of images per minute at over 95% accuracy, these systems ensure that every carrot entering the packaging stage is nearly perfectly uniform, as if it has passed through an AI-powered quality control checkpoint right on the conveyor line. After passing through the optical sorting system, not all carrots go through the same peeling process. For those that meet the standards for pre-peeled products, they are fed into a set of synchronized rubber rollers, which gently press the roots against thin blades, spinning at thousands of rotations per minute. A peel layer just 0.2–0.4 millimeter thick is removed almost instantly, enough to reveal a bright, uniform orange color while preserving the crisp flesh inside. At the same time, carrots with slightly uneven shapes are quickly rounded and refined within just a few rotations, creating the familiar form of what we know as baby carrots. Immediately after the shaping stage, the carrot stream moves on to the sizing step for commercial standards. Larger carrots are fed through high-speed rotary blade units, where they are cut into segments and precisely rounded at the ends to exact lengths. Meanwhile, smaller unpeeled carrots are handled by multi-point robotic pickers above the conveyor, which automatically orient them and trim both ends in an instant, transforming the initial flow into uniform baby carrot sticks, with a throughput of around 20,000 pieces per hour per production line. After being cut into segments, the carrots are fed into large rotating drums, where hundreds of small pieces continuously tumble, collide, and polish against each other in a constant flow of water. Under the steady rotation, rough edges are gradually worn down, and the ends are rounded off, forming the smooth, uniform shape characteristic of baby carrots in just a few minutes. Immediately afterward, they pass through a high-pressure washing system, where powerful water jets remove any remaining debris and surface residue from the polishing process, enhancing their bright, uniform orange color. At the same time, the carrots are briefly treated with microbially controlled water to reduce bacterial load and extend shelf life, before moving on to chilling and packaging. After leaving the final washing chamber, the flow of baby carrots does not go straight into packaging. Instead, they are guided onto a multi-directional distribution table, where they are evenly spread into smaller streams before entering a multi-head weighing system, where each batch is precisely measured within just a few rapid vibrations. Directly below, pre-opened packaging bags are held in place by pneumatic clamps. Once the target weight is reached, the carrots are instantly released, and the bag is sealed in under a second. The entire process runs at a speed of around 40 to 60 packs per minute, turning carrots that left the cutting line just minutes earlier into finished products, ready to appear on supermarket shelves within hours of harvest. From the moment baby carrots leave the processing line, their journey doesn't end. They are coated in a glossy layer of honey, combined with butter and garlic, then placed into a high-temperature oven. Under the heat, their natural sugars begin to caramelize, forming a lightly golden brown surface, while the inside remains tender and naturally sweet. At this point, each carrot is no longer just a simple ingredient, but a finished dish, where its natural sweetness is brought to full expression, and the texture is perfectly balanced between soft, juicy, and slightly crisp on the outside. At our first stop, we arrive in Yubari, Japan, a city that once went bankrupt after the collapse of its coal industry, yet found new life through an agricultural miracle known as the Yubari King. More than just a fruit, the Yubari King is regarded as a symbol of perfection, where each melon is the result of nearly 100 days of care with almost absolute precision. Its price has reached up to $45,000 for a pear, not simply due to rarity, but because it represents craftsmanship, reputation, and Japan's culture of luxury gift-giving. In Yubari, more than 150 hectares of modern greenhouses operate like laboratories to produce agricultural masterpieces, generating over $20 million each year. Everything begins with exceptionally selective seeds. To create perfect melons, growers use premium hybrid varieties refined over multiple generations, placed in sterile seed trays where every factor from nutrients and humidity to temperature is tightly controlled at each stage of development. After about a week, seedlings begin to form. But even at this early stage, a quiet selection process is already underway. Any plants that fail to meet the standards are removed, because the goal is not quantity, but to find the single, most perfect specimen. It doesn't stop there. Unlike ordinary cantaloupes, Yubari melons don't lie on the ground. They are cultivated in closed greenhouses. When the young plants reach about 30 to 40 centimeters in height, farmers begin training the vines to climb upward, securing them vertically and pruning excess branches so the plant can focus its growth. As the fruit develops, it hangs suspended on trellises at a height of around 1 to 1.5 meters, never touching the ground. This prevents pressure or deformation, allowing the melon to grow into an almost perfectly round shape, one of the key factors behind the value of Yubari melons. When the first flowers bloom, farmers use their hands or a soft brush to transfer pollen from the male flowers to the female ones, carefully monitoring and selecting the best fruiting position on the vine. Each plant is allowed to keep only a single fruit, All others are removed to concentrate nutrients on nurturing one perfect candidate, worthy of the title King of Japanese Melons. Over the next 60–80 days, the melons are almost entirely hand-cared for. Farmers gently rotate and massage the fruit daily, adjust its exposure to light, clean the rind, and inspect each raised net pattern to achieve an almost perfectly spherical shape. In the final stage of development, each melon is also fitted with a special paper cap to prevent sunburn and maintain an even color before harvest. Around 100 days after planting, farmers use a thin, specialized knife to gently cut the stem into the signature T-shape. The melons are then left hanging briefly before being collected in batches. The entire process is carried out with extreme care and precision to avoid any impact, as even the slightest force can affect the fruit's quality and value. However, the journey of the melon doesn't end there. With a texture almost as soft as cream, Yubari King cannot be transported like ordinary melons. Even the slightest vibration must be carefully controlled to preserve the quality of its flesh. Each melon is handled with exceptional care. Wrapped in soft protective paper, placed in an individual cushioned box, labeled with a certificate of origin, and then packed according to strict standards to prevent any movement during transit. Every detail of the packaging is designed to maintain the fruit's perfect condition from the moment it leaves the greenhouse to when it reaches the buyer. The finest specimens are then brought to the season's first auction, a symbolic local ritual, much like the opening tuna auction at Toyosu Market. As one of the most expensive fruits in the world, the flavor of Yubari melon is truly exceptional, smooth and velvety, almost melting the moment it touches the tongue. Its sweetness is delicate yet deep, spreading slowly and accompanied by a refined aroma reminiscent of cream and honey, a sensation rarely found in any other melon. Rather than being eaten like ordinary fruit, Yubari melons are typically sliced thinly, much like Wagyu, turning the experience into a ritual rather than a simple meal. In some high-end menus, they are even paired with caviar or used in premium desserts, such as mousse and millefeuille, where their sweetness is elevated into a sophisticated culinary experience. If Yubari melons are the symbol of Hokkaido, then Sato Nishiki cherries are the calling card of summer in Yamagata, the cherry kingdom of Japan, producing nearly 70% of the country's cherries. To maintain that status from the very beginning of spring, Sato Nishiki cherry trees are not allowed to grow freely, but are instead cultivated almost like outdoor bonsai. Each branch is trained on trellises, oriented toward optimal sunlight and carefully height-controlled, because even slight misalignment with the light can reduce the value of an entire cluster from the earliest days of the season. But the real challenge appears just 2 to 3 weeks after blooming. Sato Nishiki cherries are almost incapable of effective self-pollination. As a result, orchards must introduce seasonally rented bees, sometimes up to 10,000 to 20,000 per hectare, to ensure that every small flower has the chance to become a perfect cherry. And when harvest season arrives around June each year, while many cherry orchards in the United States use powerful trunk-shaking machines to harvest entire crops within minutes, Sato Nishiki orchards still rely entirely on hand-picking over the course of several weeks. Not due to a lack of technology, but because the cherry stems are so delicate that even the slightest force can immediately affect the fruit's quality. First, farmers spread waterproof plastic sheets on the ground around the base of the cherry trees to keep the harvesting area clean and to protect any fruit that might accidentally fall, preventing direct contact with the soil. At the same time, these sheets make it easier to spot and collect the cherries, ensuring that the delicate skin remains unscathed. Once this is done, pickers use low ladders to reach each cluster at the ideal height, gently lifting each cherry from the branch with almost a single touch, because even the lightest contact can cause the fruit to fall short of premium gift standards. The moment it leaves the branch, the journey of a luxury known as Sato Nishiki cherries truly begins. Each fruit is placed into grading molds, inspected for color, size, and gloss, then arranged into individual slots in trays before being boxed, a process that resembles packaging high-end watches more than handling fruit. This strict selection means that over 70% of the yield is discarded during sorting, with only the most perfect cherries retained, where their deep sweetness creates the near-perfect flavor profile of premium Japanese cherries. Sato Nishiki cherries are not just fruit, but a ritualized summer gift in Japan, where carefully selected early-season boxes can reach up to $300, because each cherry is the result of precise care and rigorous selection throughout the entire growing season. At the next stop, let's head to Thailand, the king of durian, with over 1 million tons exported each year. But the prestige of Thai durian lies not only in its volume, but also in premium Nong Hang durians that have been auctioned for up to $20,000. And despite the extraordinary price, thousands of people around the world are still willing to spend huge sums just to challenge themselves with one of the most controversial fruits on the planet. From May to August each year, during the peak of the tropical summer heat, Thailand's durian harvest season officially begins. With Nong Hang durians, harvesting is almost like a high-stakes game. When the fruit is ready, farmers use knives attached to long poles to cut the stems. But with trees reaching heights of 20 to 30 meters, things become far more dramatic. One person climbs the tree while another stays below, holding nets or sacks to catch the fruit, working together almost like a professional catching team, because a single misstep can mean losing a fortune hanging in the air. Once they leave the orchard, Nong Hang durians rarely appear in ordinary markets or enter mass processing lines. Instead, they are often sent directly to fruit festivals, showcased at high-end banquets, and gradually become a symbol of status and prestige. Leaving the durian orchards of Thailand behind, we arrive at Oishi Strawberry Farms in the heart of New York, home to some of the most expensive strawberries in the United States. For most of agricultural history, strawberries have always been a story of soil, rain, and bees. But at Oishi Farms, that story has been completely rewritten. Here, strawberries don't grow in soil. They grow in multi-layered vertical indoor farms that operate more like semiconductor factories. No rain, no pests, no contaminated soil, and no need for bees. Pollination is carried out by robots, precise and consistent, like a semiconductor production line. Temperature, humidity, and lighting are controlled hour by hour, simulating ideal growing conditions that nature can rarely maintain consistently. Beyond that, rotating growing racks, integrated with LED lighting, operate 24/7, continuously adjusting so that each plant receives the same optimal amount of light. But the most impressive moment comes in winter, when robots begin the harvest. They don't see through human intuition, they read the plants through data. The machines move along rails between the strawberry rows at a steady speed to avoid vibration. Computer vision cameras scan each cluster, analyzing color, gloss, and size to identify perfectly ripe fruit with over 90% accuracy. In an instant, a robotic arm adjusts its angle, cleanly cuts the stem, and places the strawberry into an individual tray, like handling delicate electronic components. After harvesting, each strawberry is transferred to a quality-controlled packaging area, where even the smallest imperfections are removed. The result is glossy red fruit with an intense aroma, deep sweetness, and a juiciness far beyond ordinary strawberries, almost melting the moment it touches the tongue. So what makes Oishi strawberries so much more expensive than regular ones? It's not just the technology, but the cost of maintaining a perfect ecosystem in the heart of expensive New York. From the energy required for LED systems and environmental control to the machinery, operations, and extremely low yield, each strawberry is the product of cost, time, and near-perfect precision. People often think only heads of state or billion-dollar diamonds require security escorts. But deep beneath the forest soil of Europe, there exists a delicacy that has been flown to New York by private jet with its own security team and sold at auction for up to $61,000. That is truffle, the mysterious king of the fine dining world. What makes truffle so expensive is not just its rarity, but its incredibly controversial aroma. It contains a compound called 2,4-dithiopentane, also found in the smell of damp socks or body odor. Yet when blended with dozens of other natural compounds, it transforms into a signature scent that fascinates connoisseurs, almost like an addictive, invisible luxury. There are over 200 species of truffle worldwide, but only a small number are considered truly exceptional. The most famous among them are Italian white truffle and French black truffle. To find them, hunters don't carry radar or modern scanners, but dogs worth up to $10,000. When they catch the scent of truffles, the dogs stop, circle to, lock onto the target, then gently scratch the ground with their front paws, just enough to reveal the location without damaging the fungus. In the past, female pigs were used as they are naturally attracted to the scent of truffles, which resembles the pheromones of male pigs. Sounds perfect until one problem became clear. Once pigs found them, they ate them. Because of their extreme rarity and high value, humans have attempted to domesticate truffles. However, only black truffles can be cultivated with some degree of consistency. White truffles, the most expensive variety, remain almost impossible to farm, forcing humans to rely entirely on nature. Let us begin the journey with the first stop in California, the hub that accounts for up to 90% of U.S. strawberry production, thanks to a unique convergence of coastal loam soils and Pacific Ocean fog. All operations here run like a precision-driven system, especially during the peak harvest season from April to June. Harvesting starts before dawn to take advantage of the lowest thermal conditions, allowing cellular tissue to achieve maximum stability and withstand physical handling without bruising. Unlike fresh market produce, strawberries destined for jam processing are harvested precisely at 80% ripeness to capture peak levels of natural pectin, the gelling agent that creates elasticity without the need for additives. Despite the massive scale, hand harvesting remains a mandatory standard to protect the highly sensitive skin, just 0.1 millimeters thick, equivalent to a human hair, yet responsible for bearing the full stress of deep processing. Instead of applying direct pulling force that can tear the tissue, farmers use a technique of sharply pinching the stem with their fingernails, leaving an exact 1 centimeter segment intact. This action establishes a biological barrier that shields the fruit core from bacteria and prevents premature internal oxidation. With yields reaching 40 tons per acre, California has become a strategic supply source for the global processing industry. To lock in quality, a critical 60-minute golden window begins the moment the fruit leaves the plant. Otherwise, strawberries enter self-respiratory breakdown, causing the loss of valuable sugars and aromas before they ever reach the factory. At the factory, strawberries arriving from the fields enter a rigorous industrial purification process. As the first step, all strawberries are thoroughly washed using recirculated cold water, combined with air bubbling and low-pressure spraying to remove soil and surface residues without damaging the fruit tissue. Once the washing process is complete, The strawberries are transferred to an automated stem and leaf removal system, using optical positioning combined with precision cutting blades to eliminate the green parts without damaging the fruit tissue. This step ensures uniform, fully cleaned input material free from plant debris. When only the intact red flesh remains, the strawberries are fed into cutting and primary crushing machines. Depending on the product line, the mixture may retain large fruit pieces for chunky jam, or be fully pureed to create a smooth, spreadable texture. The next step, and the most critical transformation stage, is heating and concentration. The strawberry mixture, retaining pieces or fully pureed, is cooked in vacuum kettles or indirect heated vessels at around 65 degrees Celsius under low pressure. This process activates natural pectin, removes up to 40% of free water while preserving red color and aroma, creating the characteristic thickness of strawberry jam. Next, sugar and organic acids, primarily citric acid, are precisely added to balance sweetness, gel structure, and microbial safety. The mixture is adjusted to optimal Brix levels and pH, allowing natural pectin to form stable bonds and create a uniform, non-separating gel structure. Through this standardization process, the jam can be preserved for up to 24 months, while fresh strawberries maintain quality for only a few days after harvest. At the same time, air bubbles are removed to prevent oxidation and separation. A slow stirring system ensures a smooth, uniform jam structure. After approximately 30 to 45 minutes of cooking, the finished jam is carefully cooled to around 75 to 80 degrees Celsius before entering the jar filling stage. On the automated production line, glass jars that have been cleaned are fed into the volumetric filling system, where the jam is filled while still hot, with precise volume control and minimal deviation, ensuring uniformity across products. Immediately afterward, metal lids are sealed instantly, creating a natural vacuum environment as the jam gradually cools. The combination of hot filling, vacuum sealing, and high sugar content allows the jam to be stably preserved for up to 24 months without the use of chemical preservatives. After sealing, the jam jars undergo final sterilization before entering the automated labeling line. In the final stage, the products are grouped into standard packs, ready for market distribution. At the next stop, let us head to the Aegean region of Turkey, the center of the global dried fig industry. From fig trees thousands of years old, the country controls up to 60% of the world's dried fig market, with export values reaching $250 million per year. In the Aegean region, where summer temperatures frequently exceed 40 degrees Celsius and dry Mediterranean winds blow continuously, Sarlap figs, the leading golden fig variety in the global dried fig industry, self-concentrate directly on the tree. Water evaporates slowly while sugars are retained within the fruit tissue, creating a stable, chewy texture and authentic flavor, an advantage that artificial heat drying struggles to replicate due to excessively rapid moisture removal. However, this very mechanism of natural dehydration creates the greatest harvesting challenge: asynchronous ripening. On the same branch, each fig reaches a different level of dryness from day to day, forcing more than 30,000 farming households in Aden to remain constantly present in their orchards throughout the harvest season. Harvesters use long poles to gently tap the branches. Only figs that have reached the standard dryness threshold naturally detach from the stem and fall onto nets, while fruits that are still moist remain on the tree to complete the concentration process. This method not only protects the thin, easily damaged skin, but also acts as an on-site moisture control step, reducing early risks of mold and microbial growth from the moment of harvest. Building on this level of control, the crucial drying stage is carried out based on the principle of natural convection, rather than cold drying technologies used by Americans for the Mission Black Fig variety. The figs are spread evenly on raised wooden racks for 3 to 5 days, allowing bidirectional airflow to remove moisture uniformly from the core to the skin. Once moisture levels fall to a safe threshold, the concentrated sugar content becomes sufficient to naturally inhibit microbial growth, enabling the figs to maintain stable quality for up to 12 months without the use of chemical preservatives. To meet export standards, the figs are sent directly to processing facilities for cleaning and standardization. The process begins with mechanical screening on vibrating conveyor belts, where broken figs, foreign materials, and undersized fruits are removed, leaving only uniform and intact figs to proceed to subsequent processing stages. After being cleaned and dried, the figs are hand-sorted by skilled workers. Only the finest fruits earn the tender and juicy label, certifying a soft skin, syrupy interior, and an ideal moisture level of around 24%, delivering a naturally concentrated sweetness. Finally, qualified figs are fed into vibrating hoppers and automatic weighing systems before packaging, helping preserve their soft, juicy structure and limit moisture reabsorption or oxidation throughout transportation. Highbush blueberries, accounting for up to 80% of global production, have become the star of the industry thanks to their ability to ripen uniformly, enabling large-scale mechanized harvesting. Every June, Oxbow steel giants begin their deployment across farms stretching from Oregon to Washington, USA. Their distinctive arched frame design allows the machines to envelop entire rows of bushes, moving through dense canopies without the need for cleared pathways. At the heart of the system is a dual-axis shaking unit capable of interpreting ripeness. By precisely adjusting vibration frequencies, the machine detaches only berries that have reached optimal sugar levels, leaving unripe fruit untouched. With a capacity of up to 400 kg per bin, this technology enables large-scale farms to operate 24/7, sustaining outputs of tens of tons per day. The first step in the process, and also the critical stage that determines the quality of frozen blueberries, is washing. Upon entering the plant, the blueberries are passed through a recirculated cold water washing system, combined with air bubbling and gentle water flow to remove dirt, dry leaves, and residual debris from mechanical harvesting. The entire operation is designed to minimize impact on the fruit surface, as blueberry skins are very thin and prone to cracking under high pressure. After being washed with purified water, all blueberries enter the optical sorting stage. Here, multispectral cameras scan each berry in 360 degrees, analyzing color, shape, and surface damage in real time. Any berries that fail to meet color standards or show bruising or tissue cracking are immediately removed by high-speed air jets without mechanical contact. Only berries that are round, plump, and highly uniform are retained as qualified raw material, ensuring consistency in quality, structure, and sensory characteristics from the very first control stage. Once the sorting process is complete, all blueberries are transferred to the heart of the plant, the individual quick freezing (IQF) system. The key to a frozen blueberry retaining its original character after thawing lies in freezing speed. Instead of conventional slow freezing, which can cause clumping and juice leakage, blueberries are passed through a freezing chamber with temperatures dropping to -40°C. In this environment, each berry is kept suspended by powerful streams of cold air, allowing it to freeze almost instantly and remain completely separate. This process not only locks in the fruit's cellular structure, but also freezes in the full content of anthocyanins, responsible for the deep purple color, and vitamins, the valuable antioxidants that define blueberries as a superfood. For most American children, raisins are seen as the most disappointing chocolate imposter on Halloween night. Yet behind this humble snack, a billion-dollar industry is operating at full force in California's San Joaquin Valley, producing up to 95% of the United States raisin output and accounting for 1/3 of global supply. To meet this massive demand, the OVD, dry-on-vine method, was developed and quickly became the most widely adopted standard in modern raisin production. Grapes are planted in straight rows with spacing and canopy height standardized for mechanized harvesting, supported by open trellis systems that allow grape clusters to hang freely and achieve optimal exposure to air circulation and sunlight. When the grapes reach physiological maturity, with high sugar content, approximately 20 to 24 degrees Brix, farmers cut the nutrient-supplying stem. From that moment on, the grape clusters no longer receive water or nutrients and begin to dry gradually on the vine, transforming the ripening process into a controlled natural drying process. After approximately 6 to 8 weeks, an entire vineyard that was once full of fresh grapes is transformed into rows of dried grape clusters hanging across the trellis, uniform in both moisture level and sugar concentration. That is also when specialized shaking harvesters, the familiar giants of California's raisin vineyards, enter the fields to carry out the final stage. The machines move slowly along the grape rows, using a system of flexible shaking rods that act precisely on the trunk and canes, strong enough to detach the fruit without damaging the vine structure. The dried grapes fall onto collection trays, are carried by conveyor belts into storage bins, while leaves and light debris are removed directly on the machine. Once the harvest is complete, all dried grapes are transported to the factory within just a few hours. Time at this stage is a critical factor, determining quality stability, the ability to control microbial activity, and the final commercial value of the product. After leaving the fields, raisins are received at processing plants and quickly fed into the processing line. In the first step, the raisins are poured onto vibrating conveyors and destemming drums, where dry stems and leaves are separated, while stones, soil, and large foreign materials left from mechanical harvesting are removed. Next comes the most critical stage, dry cleaning. The raisins pass through rotating drums, soft brushes, and high-pressure air-blowing systems, which thoroughly remove fine dust and surface contaminants without using water, preventing the risk of moisture reabsorption and loss of storage stability. Some plants may wash the raisins using low-pressure spray nozzles for a very short duration after dry cleaning. Immediately afterward, the raisins are dried instantly using hot air or forced airflow to prevent water uptake and microbial activation. In the next step, the raisins undergo optical sorting using color cameras and sensors, automatically removing moldy, sunburned, overly dry, or discolored berries, ensuring uniform sensory quality. Finally, the qualified raisins are weighed and packaged for retail, or packed in bulk containers depending on the intended use and export market. Standing out as one of the most iconic symbols of autumn, the pumpkin becomes the opening character in our harvest journey. Across the United States, with Illinois holding the title of Pumpkin Capital, vast golden fields come into season from late September to November, just in time for the excitement of Halloween. Fresh pumpkin harvesters use sharp blades to cut through thick stems, while mechanical arms lift the massive pumpkins from the ground and place them onto conveyor belts. Rotating rollers and brushes remove excess soil before the plump pumpkins are neatly deposited into storage bins at the rear. With a continuous rhythm, thousands of pumpkins are gathered within just a few hours. Unlike fresh pumpkin harvesters, pumpkin seed harvesters have a more specialized design. These machines crush and separate the entire fruit directly in the field, sorting out the seeds through screening systems, while the rind and flesh are discharged back onto the soil as organic fertilizer. By combining these two technologies, American farmers not only meet the enormous demand for fresh pumpkins in holiday markets and food production, but also maximize economic value from the seeds, driving annual yields to more than 680,000 metric tons. Farewell to the diligent farmers across the fields of Illinois. Now let us journey to Wisconsin and Massachusetts, where every September, farmers harvest their rewards, glistening like crimson jewels upon the water. Unlike pumpkins, cranberries are harvested using a unique method known as wet harvesting. When the season arrives, farmers flood the bogs with water, then deploy special machines called water reels or egg beaters to stir the vines and loosen the berries. Thanks to tiny air pockets inside, cranberries rise and float, creating a spectacular sight. Thousands of bright red berries drifting like a floating carpet across the water's surface. Next comes the conveyor harvester, a modern harvesting machine that drives directly through the flooded bog. At the front, steel tines sweep the floating berries into the intake, while rotating conveyors lift them up, drain the water, and deposit them straight into boats or bins along the bog's edge. This method accelerates collection, reduces the need for manual boom corralling, and minimizes damage, making it ideal for large-scale cranberry farms in the US and Canada. Much like the bison roaming the Great Plains, the sight of flooded bogs shimmering with cranberries has become an enduring symbol of North America, a living image that captures both its natural abundance and cultural identity. Another approach that is becoming increasingly widespread is the conveyor harvester, which demands an investment of $250,000 to $400,000, but delivers far greater efficiency. At the front, steel tines sweep the floating berries toward the intake, where rotating conveyors lift them up, drain away the excess water, and deposit them directly into waiting boats or bins along the bog's edge. Each year, harvesting 700,000 tons of cranberries can require millions of liters of water, but Ocean Spray, the largest farmer-owned cooperative in the United States, emphasizes that much of this water is reused throughout the season, while accounting for nearly 70% of the nation's production. Brussels sprouts grow in tall, sturdy stalks that can reach up to a meter in height, with dozens of compact green buds tightly clustered along the stem, making their harvest a task that requires both precision and specialized machinery. From September to March each year, the Brussels sprout fields in Flanders, the agricultural heart of Belgium, enter their harvest season. Farmers rely on specialized machines such as trailed Brussels sprout harvesters and self-propelled Brussels sprout harvesters. Inside, 6 rapidly rotating blades spin like a giant pencil sharpener, trimming each compact sprout and pushing the stalk forward. Every 6 seconds, one plant is fully processed. The Brussels sprouts are then cleaned by fans and filters before falling into the collection hopper. Thanks to scientific farming methods and highly efficient mechanization, Belgian farmers harvest more than 156 million pounds of Brussels sprouts each year, surpassing other countries such as the Netherlands, Germany, and the United Kingdom. Nearly 90% of the products we use every day contain sugar, and much of that sweetness begins in the sun-drenched sugarcane fields of Brazil, where farmers harvest around 650 million tons of cane each year. During the 2025 season, Brazilian farmers must race against time to cut and process sugarcane before it is sent for crushing and export. Before the 2000s, both American and Brazilian farmers commonly burned sugarcane fields before harvest, especially in São Paulo state, which produces more than half of Brazil's output. It might sound unusual, but the purpose was to remove dry leaves and unnecessary tops. This left the stalks cleaner, reduced excess debris such as fallen leaves, organic matter, and insects, and made manual cutting faster and more efficient. However, because of the enormous amount of smoke and harmful emissions it generated, Brazil has implemented a program to almost completely eliminate pre-harvest burning, shifting instead to mechanized green cane harvesting. But in the United States, especially in Florida, burning sugarcane before harvest is still common. If you were there, how would you explain the reason behind it? Against this backdrop, harvesting fresh, unburned sugarcane with modern machinery is increasingly being promoted and has quickly become the dominant path forward. Specialized harvesters cut the cane close to the ground while simultaneously stripping leaves and tops right in the field. The stalks are lifted onto trucks by conveyor belts and transported straight to the mills on the same day. If the harvest is delayed, the sugar content in the cane drops rapidly, making it prone to mold and pests, which reduces its market value. That is why Brazilian farmers always strive to deliver the cane to the mills within 24 hours to ensure the best quality.